Alright, let's solve this geometry problem carefully, step by step, because the entire solution is built around one very important repeating idea. We have two straight lines, PV and PW, meeting at point P, and the angle between these two lines at P is the unknown angle X. Along the lower line, the points appear in the order W, U, S, Q, P, while along the upper line, the points are V, T, R, P. We are also told that there are 7 marked segments, namely PQ, QR, RS, ST, TU, UV, and VW, and all 7 of these segments have the same length, which is 6 units. Finally, the angle at V outside the large triangle is given as 98 degrees, and our job is to find the value of X. Now, before we start calculating, remember that the diagram is not necessarily drawn to scale, so we should not judge the angles just by looking at the picture. We have to use only the information given to us, especially the equal lengths and the angle relationships. Let's begin from the right-hand side with triangle PQR. Notice that PQ and QR are equal in length. Whenever two sides of a triangle are equal, the triangle is called an isosceles triangle, and the angles opposite those equal sides must also be equal. So triangle PQR is isosceles. The angle at P is our unknown angle X. Therefore, the angle at R, which is the angle opposite the equal side PQ, must also be X. So at this point, we have one angle X at P and another angle X at R. Now let's look carefully at what happens when we consider the exterior angle at R. The exterior angle theorem tells us that an exterior angle of a triangle equals the sum of the two remote interior angles, meaning the two interior angles that are not adjacent to that exterior angle. Here, those two angles are X and X. So the exterior angle at R is X plus X, which gives us 2X. This is our first important step because we have created our first multiple of X. Now we move one triangle to the left and consider triangle QRS. Again, look at the marked segments. QR and RS are equal. So triangle QRS is another isosceles triangle. That means its two base angles are equal. From our previous step, the relevant angle at Q is the 2x angle that we just obtained. Because the triangle is isosceles, the matching base angle at S must also be 2x. So we now have another angle measuring 2x. Next, we look at the larger triangle PRS and focus on the exterior angle at S. Once again, we use the exterior angle theorem. The exterior angle is equal to the sum of the two remote interior angles. Those two angles are the 2x angle we just found and the original x angle at P. So, let's add them carefully. 2x plus x gives us 3x. Therefore, the exterior angle at S is 3x. Notice what is happening here. We started with x, then the equal sides allowed us to transfer that angle, and the exterior angle theorem added another x. That is why the angle has increased from 2x to 3x. Now we move one triangle farther to the left and examine triangle RST. The two marked sides RS and ST are equal, so triangle RST is isosceles. And because the relevant base angle coming from the previous step is 3x, the matching base angle must also be 3x. So, the angle has now progressed to 3x. Next, we consider the larger triangle PRT and apply the exterior angle theorem again. The two remote interior angles are 3x and x. Therefore, the exterior angle is 3x plus x, which equals 4x. So our sequence continues. We have now reached 4x. Let's pause for a moment and recognize the pattern, because this is the key to the entire problem. Every time we move to the next equal length segment, we form another isosceles triangle. The equal sides force the corresponding base angles to be equal, and then the exterior angle theorem adds the original x angle. That is why we keep increasing by exactly x each time. Now, let's continue. Consider triangle SU. The marked segments ST and TU are equal. So triangle STU is isosceles. Therefore, its corresponding base angle is also 4x. Now we move to the larger triangle PUS. Applying the exterior angle theorem once again, the two remote interior angles are 4x and x. So the exterior angle becomes 4x plus x, which equals 5x. Therefore, the next exterior angle is 5x. We continue in exactly the same way. Triangle TUV is isosceles because TU and UV are equal. Since the corresponding angle from the previous step is 5x, the matching base angle in this triangle is also 5x. Now consider the larger triangle PUV. Using the exterior angle theorem, the exterior angle is the sum of the two remote interior angles, which are 5x and x. Therefore, 5x plus x equals 6x. So we now have an angle measuring 6x. Next, we move to triangle UVW. Again, the equal length condition gives us the isosceles triangle we need because UV and VW are equal. Therefore, the corresponding base angle is also 6x. Now, we are almost at the final step. Consider the large triangle PVW. Applying the exterior angle theorem one last time, the exterior angle is the sum of the two remote interior angles. Those angles are x and x. So we calculate 6x plus x, which gives us 7x. And this is the crucial result. The angle at V was given in the problem as 98 degrees. At the same time, our repeated use of the isosceles triangle property and the exterior angle theorem has shown that this same angle is 7x. So we can equate the two expressions. We have 7x equals 98 degrees. Now, we simply need to solve for x. To isolate x, divide both sides of the equation by 7. So x equals 98 divided by 7. And 98 divided by 7 is 14. Therefore, x equals 14 degrees. So our final answer is 14 degrees. If this step-by-step geometry solution is helping you understand how these repeating angle patterns work, take a moment to like the video, subscribe to the channel, and leave a comment with your answer before moving on to another problem.